Hello everyone, I'm Karthik from Team IDLI. I'm going to be talking about our project on extracting causal relationships from text. So our task is twofold. The first part is identifying if a given piece of text exhibits a causal relationship. And the second part is given a causal relationship, we attempt to identify the spans of text which corresponds to cause and that which corresponds to effect. So as we all know, finance forms a large part of our daily life, and there is an exponential growth today on the number of financial articles being published every day. Being able to automatically parse them and extract insights would be of great use for people who study this data, like journalists or financial analysts, which they can then use for generating narrative summaries or for question answering and other downstream tasks. And the data as such is extremely unstructured, and there are various different ambiguous ways to express the same cause and effect relation, which makes this problem really interesting slash challenging. uh, so we are participating in a shared task and calling conference, and we are using the data set that was released along with that task. As you can see, for task A, it's heavily biased towards negative examples. And as an example, you can see here that there is a sentence which does not have a cause or an effect, so we mark it as a 0. And for task B, you can see that there is a sentence coupled with its label for every word. You can see here that Tony lost 9,000 bitcoins in a single day, which caused him to be 60 million won in debt. So we are required to label the span of losing 9,000 bitcoins in a single day as a cause, and Tony finding himself 60 million won in debt as the effect. Um, so the baselines for these are the ones that are recommended by the task organizers. So they released really strong baselines for both the tasks. So for the first task, they released a BERT based model, which is purely like an attention based transformer model, which is generally used to extract features from sentences, which on top of which people perform classification, and it's currently the state of the art for many NLP tasks. And the baseline for task B is a conditional random field, which again is the state of the art for many sequence labeling tasks like named entity recognition or part of speech tagging, etc. You can basically think of them as a discriminative equivalent to hidden Markov models. So the first model that we tried was a convolutional neural network for text, which was initialized using glob embeddings. We ran filters of multiple sizes with polling and a dense layer with softmax. We used a weighted cross entropy loss to train the model as we were optimizing for F1 score. And the second model that we tried was we tried re-implementing the state of the art as a BERT classifier, and on top of which we used a custom financial version of BERT to better understand these constructs. And for task B, we initially implemented a QA based model to identify spans in text corresponding to cause and effect. So, for example, if we had a sentence, we asked a question like what corresponds to the cause, and we took the span that it predicted and we used it. And as our second model, we implemented sequence labeling with BERT, where we marked each token as cause, effect, X, or other. So the token X was necessary because BERT works on word piece embeddings and not word embeddings. So we had to mark the split word pieces as X. So these are the results where with our CNN model, we achieved a 94 F1, and our BERT model closely rivaled the state of the art with very similar results. And with the financial version of BERT, we were able to exceed it. And for task B, so the baseline F1 was about 60, and our sequence labeling BERT model was able to achieve an F1 of about 68.8. So we performed some error analysis to see where our model could be improved further, and we identified certain patterns of errors. So the first one was where there was text with multiple cause-effect relations. For example, you can see COVID caused a drop in oil prices. This price fluctuation resulted in multiple layoffs. So there are two causes here, COVID and the price fluctuation, and our model actually picked up on both of them, while the annotators only required us to annotate COVID as a cause. So we need to implement some kind of post processing for this. Similarly, there were cases where our model didn't pick the maximal span. For example, our model picked 60 million won indebted when it should have picked Tony found himself 60 million won indebted. So we plan on incorporating a post processing module which can incorporate these annotation rules and stretch the spans to account for the annotations better. So that's it for our presentation, and given that we were able to beat the state of the art on both the tasks, we plan on completing our work and writing a paper to calling later this year. Thank you.